Hi guys. As I already said that in this playlist we will be discussing the most important questions for MECA semester examination for DSA, data structure and algorithm, third sem students. Okay, so here our first question is, what is the structure? What is a structure and what is the difference between structure and arrays? What is the difference between structure and arrays? So when different type of elements have to be put in a single unit, like character, float, uh, some other data types also, we all those all data types should be kept in one single structure, one single data structure. Then in that case we use this structure. This is a and this struct is the keyword while initiating any structure format. This is the syntax for structure. Okay, so here student is the structure tag, and roll number, name, marks are structure elements or members. S1 is a structure student type of variable with a size of 30 to 36 bytes, comprising of roll number, name, marks, and in a sequential order. So here we all we all knew that in array it is a linear data structure, and here we can only store the same type of elements. Like the data type will be same for all the elements. Like if you are storing some integer data type, then all those elements of the array data structure will be in integer type. And but in this case we can store some float data type, some character data type, some integer data type, all in this one format. So what are the differences between arrays and structures? As you can see here, an array is a collection of related data elements of the same type. This is the main important thing. And here, the structure can have elements of different types. As I explained before, an array is a derived data type, but a structure is a programmer-defined data type. Any array behaves like a built-in data types. All we have to do is to declare an array variable and use it. But in case of structure, first we have to design or declare a data structure before the variable of that type are declared and used. Array allocates static memory, means array use static memory allocation, whereas structure use dynamic memory allocation. These 2 points, number 1 and number 4, these 2 points are very important difference between arrays and structure. If you write down these two main points in your exam, then this will be a very positive part of your answer paper. So an array is a pointer to the first element of it, and structure is not a pointer. Element access takes relatively less time. Property access takes relatively large time, as it is a dynamically allocated memory. That's why it takes large time while accessing it. What is a self-referential structure? Explain with example. A self-referential structure is a structure which has at least one member which is the same type as the structure itself. It is different from ordinary structure because it has at least one structure pointer of its own type as one of its members. For example, a self-referential structure can be declared in this following way. You can see here. The above mentioned structure declaration contains next pointer which is of the same type as the structure itself. You can see here. This is the structure name. student, and here this next pointer pointing at this student structure. That's why this is a self-referential structure. Coming to the next question, that is, what is the static and dynamic memory allocation? This is the most important question for Macau third semester examination for DSA. So, what is the difference between static and dynamic memory allocation? We have to remember one point, that is arrays. Array uses static memory allocation and linked list. Linked list uses dynamic memory allocation. We will be coming to the linked list portion after this video, or maybe in this video also. So we will be learning that later. But for now, what is static memory allocation? It refers to the memory allocation at compile time. Means we have to assign the value before, we have to write the syntax before we run the code. Before we run the code at the compile time. At the compile time, the memory will be allocated. So, as we all know that in array, we have to write the the array data type. We have to initialize the array data type, or we have to give the size, that how much array elements can be stored in this particular data. We have to name it like this. There is a syntax and we have to initialize it like that. But for dynamic memory allocation, it means allocating memory at runtime. That means at the runtime, in the heap portion of ran, random access memory, at runtime, the memory is allocated, resulting in a better utilization of memory. We have to remember one thing, that static memory allocation for arrays and dynamic memory allocation for linked list. We use malloc and calloc function. So there are some particular reasons for using these two functions. For creating a memory dynamically, we normally use this malloc function. We will be seeing later that in linked list, this malloc function is hugely used in linked list for creating memory location dynamically. This is the example. You can see this is the syntax for creating dynamic memory allocation, and if memory allocation fails, malloc returns null pointer, but normally malloc returns a void pointer. This is very, very important for MCQ type questions, that malloc returns void pointer. But if the memory allocation fails, then malloc returns null pointer. So what is calloc? Calloc is similar to malloc, but the main difference is that the value stored in the allocated memory space is 0 by default. Means at that point where the memory is allocated, the space is 0. Memory space is 0 by default. With malloc, the allocated memory would have any value, like it has dynamically created a address, or dynamically created a memory, and it has any type of address. But for calloc, it is by default 0. What is realloc? Realloc deallocates the old object pointed to by ptr and returns a pointer to a new object that has the size specified by size. That means realloc is used to deallocate memory. The one point to be noted is that realloc should only be used for dynamically allocated memory. To deallocate the dynamically allocated memory, we use this realloc function. If the memory is not dynamically allocated, then the behavior is undefined. What is the difference between static and dynamic memory allocation? We have studied this before on the first lecture, so we'll not be going to study it here in this lecture. So I am skipping this question. Coming to the next question, what is free function and what is memory leak? Free function is used to deallocate the memory block which is no longer needed. For example, free PTR. That means this PTR function or this PTR variable will be reallocated. A memory leak occurs when memory is allocated using malloc function and not released using free function. That means a memory is created using malloc function, but it is not released using the free function. These result in orphaned block that allocated memory is no longer needed, but still it is there in the memory. It is not reallocated by this free function. Then it become an orphaned block which is not referenced by anything. It become an orphaned block. Then memory leak occurs. Memory leak arises due to the following reasons. Memory blocks allocated are not released even when not required. The free statement is bypassed at the time of execution of the particular program. The memory allocated by malloc function is stored in a pointer variable which is already pointing to another memory location. And now this block become an orphan. So this memory leak occurs. Come to the next question, that is what is linked list? Advantage and disadvantage of linked list. Linked list is a linear data structure. It is a dynamic or linear data structure in which memory of each node is allocated at runtime for the heap portion of the RAM. You have to remember this heap portion of the RAM. So the memory allocation for the nodes need not to be continuous as in the arrays. Like if the memory is allocated at the address 900, then the next node can be allocated at the next at 1000 or any other position. This needs not to be in a continuous way. Insertion and deletion can take place from the beginning, middle, or end. There are the various types of linked list: single linked list, double linked list, circular doubly linked list. Advantages of linked list over arrays. What are the advantages of linked list over arrays? This is the very important question that often comes in data structure and algorithm question paper for MACOUT exam. As memory allocation is done at runtime using a linked list, results in a better memory utilization. This is because we end up creating only as many nodes as required by the user. Neither there is a wastage of memory nor a shortage which might happen in case of arrays. Like in case of arrays, we have to initialize before. We have to initialize before that how many elements can we insert in an array. We have to initialize the size before in case of arrays. But in case of linked list, uh, the, we can we can create as many nodes as required by the user. We can create as per our requirements. As in a linked list, the nodes are not allocated continuous way. Again, this results in a better memory utilization. Insertion and deletion also simpler and less time consuming comparatively to arrays. What are the drawbacks? Random access is not allowed. Like we have to access it sequentially. We have to access elements sequentially. Starting from the first node, we have to access it. No extra memory space for pointer is required with each element of the list. These are some drawbacks between arrays and linked list. What are the operations which can be performed on linked list? traversing, searching, insertion, deletion, sorting. Each and every operation can be easily performed in linked list. Also merging. What is a single linked list? How it is to be implemented? A singly linked list or a single linked list is like this. It contains two parts. One is information part and another is link part. This link part contains the address of next node, while this information part contains the data. Simply the data or the information you want to push, or you want push means you want to insert, or you want to delete. So the definition of single linked list: a linked list whose node contains two parts, information part and the link part. This null value is presented in the link part at the very beginning. So this is the simply structure of a linked list. Nodes are created for linked list at runtime. Nodes are created at runtime using memory allocation function malloc. This is the main memory allocation function by which we can create linked list at runtime. This is the referential structure by using this struct node, and this is the syntax for your creating a linked list. Here you can see this very first node is called head. This very first node is called head. It is pointed. This is pointed by a head pointer. This node is pointed by a head pointer. In linked list, this is one node, this is one node, this is one node, and these all are connected or linked. That's why this is a linked list, where this part contains the data part and this contains the link part of this node. This part contains the link part of this node. From the very beginning, when there is no other next nodes are created at first, this part contains null value. This link part contains null value at the very first time when there is no other next nodes are there. Okay, so each element we call it a node. For a link, for a list comprising of two items, the data and reference to the next node. The last node has a reference to null. The entry point into a linked list is called head. The entry point of a linked list is called head of the list. It should be noted that the head is not separate node, but the reference to the first node. It is not a separate node, it is the reference to the first node. If the list is empty, then head is a null reference. That means head is a null reference. We all know that here it contains the null value when there is no other next nodes present here. So what are the application of single linked list? Linked list can be used to implement stack, queues. Linked list can be used to implement graphs and many more. You can see these all are the application for linked list. What are the advantages and disadvantages of single linked list? Insertion and deletion can be done easily. It can be extended or reduced according to the requirements. It is less expensive. But the disadvantages are it requires more space and pointers to be allocated with information, and we cannot traverse it from last and only from the beginning. We cannot traverse it from the last but only from the beginning. It is not easy to sort the elements stored in the linear linked list. Sorting is not easier in linked list, and this can be the disadvantage. What is a doubly linked list? What is a doubly linked list? Doubly linked list contains one previous part, one information part, and one next part. Okay, so the definition is in a doubly linked list, each node contains transformation information part and two pointers. This is the previous pointer that contains the value for previous node. Address. The address of previous node is stored here, and in this next pointer, the address of next node is stored here. This is the syntax. You can see this is the syntax for creating a doubly linked list, mainly for creating these three pointers. It has a pointer start pointing to the beginning of the list and a pointer last pointing to the last node of the list. A node, a doubly linked list is represented using the following self-referential structure. You have to remember one thing, that linked list can be represented using only self-referential structure. I mean the syntax is like this. And doubly linked list contains previous pointer and next pointer. That means it contains the address of the previous node here, and it contains the address of the next node here. So what are the advantages and disadvantages of doubly linked list? You can see there are so much advantages in doubly linked list because deletion can be easier. Uh, as like single linked list, it is easiest data structure to be implemented and can allocate or deallocate memory easily. But for disadvantages, it uses extra memory because it contains the uh, link, or it contains the address part from the previous node as well as also from the next node. That's why this is a little complicated while implementation. Not many, but doubly linked list has few disadvantages. And I just said to you all guys. So, what are the application uses of uses of doubly linked list in real life? I'm not going to explain this guys because this is the theory part and you have to memorize these all questions for your exam purpose, and these are not that much tough to be understand that I have to explain, but you can just read this and you have to remember it. You have to memorize it for your exam purpose. Okay. So what is a circular linked list? Circular linked list means this last in this last node that in this last node this link is connected to the first node. Okay, so this last node, this link part, in this link part is this link part contains the head address of first node. In circular linked list, it is one of the linked list in which last node of the list, rather than containing a null, it contains the address of starting node. Last node does not containing any null point, any null value. It is containing the address of the head pointer of the first node of the linked list. Thus, the last node points back to the start node of the linked list. So how it is advantageous over single linked list? What are the disadvantages of circular linked list? Advantages of circular linked list over singly linked list. Here, any node can be a starting point. We can traverse the whole list by starting from any point. We just need to stop when the first visited node is visited again. Useful for implementation of queues. Unlike this implementation, we don't need to maintain two pointers for front and rear if we use circular linked list. We don't need to maintain two pointers. In case of single linked list, we usually maintain two pointers. One is front and one is rear. But in case of the circular linked list, we do not need to maintain two pointers, and that is the most advantage of circular linked list over singly linked list. Circular lists are useful in application to repeatedly go around the list. For example, when multiple applications are running on a PC, it is common for the operating system to put the running applications on a list and then to cycle them around, giving each of them a slice of time to execute, and then making them wait while the CPU is given to another application. Circular doubly linked lists are used for implementation of advanced data structure like stack, queue, graphs, and trees, etc. These are the disadvantages. It is not easy to reverse the linked list when it is a circular linked list. It become much more complicated while implementation, and infinite loop may occur, and instead we have to complete the entire circle by going through the in between nodes. We will reach at the required node. This is if we add a node and go to the previous node, then we cannot do it in a single step. As this is a circular linked list, this become much more complicated when if we are at a node, we go back to the previous node. We can't go back to the previous node like this. You can see here we are presenting in this node, so we can go back to the this node like this. We have to traverse from again, we have to traverse from here, we have to go this to this and this and this, and then finally we will be coming to this node. So traversing is not that much easier for singly linked for circular linked list. What are the applications of circular linked list? The next type is doubly circular linked list. What is doubly circular linked list? Doubly circular linked list has the properties of both doubly linked list as well as the circular linked list. Means uh, you can see here this is the drawing of the doubly circular linked list, and here this last link part is containing the address value of this first node. This last link part containing this value of the first node, as well as this this first node link part containing previous node value that is from the last node. Means this address will be stored here at the previous node part of the first node, and this this node address will be stored here at the link part or the next node part of the last node. So this is the syntax. And one more thing, that is linked list in which two consecutive elements are linked or connected by previous and next pointers, and the last node points to the first node by the next pointer, and also the first node points to the last node by the previous pointer. This is the main property of doubly linked list. This is the main property of doubly circular linked list. We will be taking a single lecture on these particular topics, as these topics concept must be cleared for your exam. so that you can write by yourself according to the question given to you. Concept must be cleared. Concept must be cleared for your exam, because when some unknown type question comes, some unknown type um, theory type question comes, then you can write it by yourself if your concept is clear. That's why I will be taking a single lecture over this circular linked list, because the concept need to be clear. Insertion at the end of list in an empty list. So empty list, where start is equal to null, then it points, this part points itself as well as this part point itself also. Uh, List initially contains some node. Start points to first node and uh, first node of the list. A node is inserted with data is equal to 7. So the previous pointer of m points to the last node. Means suppose this is our first node. This is our first node. And next we have to insert uh, and this is our last node. Okay, we have to insert the new node, that is 7. We have to insert the new node, that is 7. And this is our existing linked list. And we have to insert this new node. We have to insert this new node. So this pointer will be at this position. This pointer will be cancelled from here and will be at this position, and this part will be containing the address of this new node. This part will be containing the address of this new node. Okay, so you can see, and this last pointer part will be cancelled out from here to here, and it will start connecting from here to here. Now this insertion process, now this insertion process is done. So this is the insertion process for doubly circular linked list. What are the advantages and disadvantages of circular doubly linked list? This is also an important question. And what are the applications of circular doubly linked list? So this is all about today's lecture, and please feel free to subscribe and share, like, comment. And if you are facing any type of problem while understanding, while clearing your concept, do comment in the below comment section. And also for getting the notification before everyone, please do subscribe, and thank you.